So kapag nagsosolve naman tayo ng trigonometric functions, specifically under limits at infinity and infinite limits, malaki ang naitutulong ng graph ng bawat functions. Okay? So we need to inspect the graphs of each trigonometric function and later we'll determine the limits. Let's have the first, the sine and cosine function. The sine and cosine functions are most popular trigonometric functions. This is the graph of y that is equal to sine x. Now, if you're going to observe what happens to the values of y when x keeps on increasing, or the values of x that keeps on decreasing, at bakit siya naging d and e? Okay, the reason why the limit of this trigonometric function sine as x keeps on increasing or decreasing does not exist dahil sumasayaw ang values ng y. Meaning to say, papunta sa negative 1, tapos aakyat sa 1, bababa ulit, aakyat, bababa. So, ibig sabihin, dalawang pinupuntahan niyang values. The lowest, negative 1, the highest, 1. So, you cannot exactly say what happens to y because you cannot say that y keeps on increasing kasi hindi naman umaakyat ang values ng y. Hindi mo rin kayang sabihin that y keeps on decreasing kasi bababa man siya pero aakyat ulit as you can see on the graph. Kaya ito, TN. The same is also observed sa graph ng y that is equal to cosine x. Dahil nga aakyat and then bababa tapos aakyat ulit. Tuloy-tuloy siya ng kanyang movement. So kapag tinanong ka, as x keeps on decreasing or x keeps on increasing, well, you don't know exactly what happens to y. Dahil nga sumasayaw ang values ng y. Hindi mo yan kayang sabihin na TNE, hindi mo rin kayang sabihin na positive infinity, but you can say the limit does not exist. Okay? Actually, hindi naman na tinatanong ang ganitong function when the abscissa keeps on increasing or decreasing. Hindi na tinatanong ang mga yun. Kasi ang tendency, wala naman talaga limit. Okay? But you just need to be acquainted because when it comes to two-sided limits or when it comes to infinite limits, you are observing the behavior of the entire function, the graph. However, when we talk about tangent and secant function, ang kailangan nating maintindihan dito is the domain. Ang domain niya, lahat na sana ng real numbers, kaso bawal ang mga ito. The general solution here, x should not be n pi plus positive infinity. At ano ba ang mga ito? Ito yung mga pi over 2, positive negative pi over 2, positive negative 3 pi over 2. Ang mga ito ay bawal kay tangent and secant function. So, tinan natin ang graph ni tangent. Makikita natin na sa graph niya, ang x that is equal to pi over 2 ay hindi na siya parte ng domain. Katulad din ni 3 pi over 2, negative pi over 2, negative 3 pi over 2. Tuloy-tuloy yan, infinite yan. Kaya nga, naka-general solution yung bawal. Ngayon, mapapansin natin na kapag tignan mo yung left ng pinagbabawal na value. So when you keep on approaching pi over 2 from the left, ang ginagawa ng y keeps on increasing. Wherein, when x keeps on approaching pi over 2 from the right, anong ginagawa ng y? Ito siya. Y keeps on decreasing. So parang may clue, laging may clue na mapapansin natin kay tangent na kapag nasa left, will always positive infinity. Pag nasa right is negative infinity. Kaya nga, class, if you remember, when you are asked to determine what is the limit of tangent x as x approaches pi over 2, the answer is t and e. This is already introduced to you. Remember that. Okay? Kasi nga, when it comes to left of pi over 2, a positive infinity. When it comes to right of pi over 2, then that becomes negative infinity. So by behavior, hindi naman talaga sila pareho na pinupuntahan. That's why it's D and E. Okay? What about for the second function? Si second function, makikita natin negative pi over 2, pi over 2, 3 pi over 2. Ito yung mga pinagbabawal na values sa kanya. But you have to be very conscious kasi magkaiba ang tinutukoy ng left at right. No? Kikita natin dito, when x keeps on approaching negative pi over 2 from the left. No? Ito ang left, so ang ginagawa ng y. Okay? Y here keeps on decreasing without bound. But when x keeps on approaching negative pi over 2 from its right, ang ginagawa ng y ay tuloy-tuloy sa pag-increase. So pag gawin mo siyang limit problem, the limit of second x as x approaches, no, pi over 2, or let's say negative pi over 2, your answer is D and E. Kasi yung left at right, iba ang pinupuntahan nila, no? Yung left ay papunta sa negative infinity, ang right ay papunta sa positive infinity. But you have to be very observant on the behavior of the graph. Let's say, what is the limit of second x as x approaches 3 pi over 2 from its right? Ito siya, no? 3 pi over 2 from its right is obviously, this is 3 pi over 2, and ang right niya, yung ginagawa ng y keeps on increasing. So when x keeps on approaching 3 pi over 2 from the right, then y keeps on increasing. So the answer here is positive infinity. Another, when you're going to get the limit of second x as x approaches pi over 2 from the right. This is pi over 2. Ito yung right niya. This is negative infinity. Right? Pababa siya. So this is negative infinity. Now, pwede ding i-guide ka ng graph ng sine function. Kasi yung graph ng sine function, class, will definitely show to you also. Ito yung graph ni sorry, this is the graph of cosine. I mean, this is cosine. The graph of cosine function. So, parang kapag na-reach mo yung highest point, saka naman paakyat si second function, no? Na-reach mo yung lowest point, pababa naman si second function. So, that is the behavior. Tuloy-tuloy lang siya. So, if we check other examples, ayan na yung sinasabi natin, no? The term does not exist, which exactly what we had already on the past week. Okay. Now, other examples are shown here. Pero kapansin-pansin mo si tangent, kapag left, no? Pag left of tangent will give you positive. Left ng bawal sa kanya is positive. Pero yung right niya, yung right naman, okay, ay negative. So you see, this is right, this is negative. Pero kapag two-sided limits na, just like x approaches negative pi over 2, that becomes negative infinity. Kasi itong dalawang ito ay magkaiba ang pinupuntahan. No? They are infinite ang limit, pero iba ang behavior bawat isa. Kung sana pareho silang positive infinity left at right, then in two-sided, this must be positive infinity. Observe also, just need to be very careful now observing second function, because when you take a look into the graph of it, left of negative pi over 2, this is negative pi over 2, left niya is negative infinity. That's why it's negative infinity. So it really helps a lot, no, to observe the graph. Or you can do an assumption also. Okay, this can help also in inspection. Kuha ka ng isang value na pinakamalapit kay negative pi over 2 from the right, sa right niya. Makikita mo na positive ang magpapakita sa'yo na value. Kaya sagot mo dyan is positive infinity. Okay? Pero kapag kumuha ka ng value ng negative pi over 2 na galing sa kanyang left, negative ang ipipigay niya sa iyo. So, ang clue, when that's negative as a resulting value, negative infinity ang ibig sabihin ng limit. Okay? Habang nilalapitan ng negative pi over 2. Now, let's move to cotangent and cosecant function. Itong dalawang nito naman, bawal sa kanila ang x that is equal to n pi in its domain. At ano mga yun? We have 0, pi over pi, 2 pi, 3 pi, 5 pi, ganyan. Where n is an integer. Okay, pag tignan natin yung graph ng cotangent, ito, bawal sa kanyang 0, di ba? So, x equals 0 is a vertical asymptote. And so, with pi, 2 pi, 3 pi, mga yan, negative pi, negative 2 pi. At makikita natin na, for example, when x keeps on approaching pi from the right, ang y naman ay tuloy-tuloy sa pag-increase. You see this? Akyat siya. Pero pag tinan natin yung left ng pi, ang ginagawa naman ng y ay tuloy-tuloy sa pag-decrease as shown here. So pag ginawa mong limit problem yan, limit of cotangent of x as x approaches pi from the right is positive infinity as shown on the graph. Or the other way around, tuloy-tuloy lang din kasi yan class, ganyan ang kanyang movement. Limit of cotangent of x as x keeps on approaching negative 2 pi from the left, then the answer is negative infinity, as you can see here. But since left goes to negative infinity and right goes to positive infinity, kapag two-sided limits naman na yan, ang sagot nyo is t and e, just like this. So x approaches negative 2 pi. Hindi na ipinakita kung left or right, no? Hindi na niya pinakita, so ang sagot mo dyan is t and e. Bakit kaya? Because negative 2 pi is not allowed to be, that's undefined on cotangent pi. Or cotangent x, right? When x is negative 2 pi. Also, when you check the left of negative 2 pi, it gives you already negative pi. And when you check right of negative 2 pi, no? Ang ginagawa ng y keeps on increasing. So, negative infinity versus positive infinity is actually giving you the reason why the limit does not exist in this case. Now, observing the graph of cosecant function, pareho sila ng vertical asymptotes kay cotangent. Pero kapansin-pansin din, no? Ang nagiging basis natin dito ay yung graph ni sine function na kapag paakyat si sine function, saka naman paakyat ang values ng cosecant. Pag pababa ang values ng sine function, pababa din naman ang values ng cosecant functions. Okay, so halimbawa dito, if you're going to observe when x approaches negative pi from the left, ang ginagawa naman ng y ay paakyat. So ito siya, left ng negative pi. Or when we check ito si 2 pi, let's say x approaches 2 pi from its left, ang ginagawa ng y keeps on decreasing. So this one is a graphical analysis of limit. Pero posible din na pwede kang class. Let's say, what is the limit of cosecant x as x approaches 2 pi from the right? So what must be your answer? The answer is positive infinity. You know the reason, class? Okay, kapag ituloy mo pa to, akyat yan yan, tapos pag ganyan siya, pag ganun na yung graph ni cosecant function. Ang pwedeng makatulong sa inyo is kuha ka ng pinakamalapit kay 2 pi na, okay, kuha ka ng pinakamalapit kay 2 pi na value. Tapos kunin mo ang kanyang cosecant of 2 pi. Ang magpapakita sa iyo is positive na sagot. Ibig sabihin nun, class, kung ito kasi yung 2 pi at kukuha ka ng numbers na very close to 2 pi na pinakamalapit kay 2 pi, aakyat talaga. Positive ang mga makukuha mo dito. Na siya naman kabaliktaran, let's say kay 3 pi over 2. Kumuha ka ng kay pi, for example. Or definitely sa left ni 2 pi. Kuha ka ng nasa left niya. Mapapansin mo na negative ang mga ipapakita niya sa iyong sagot. So, isa yun sa clue. And other examples are already found here. And again, when it comes to two-sided limits, lahat ng mga pinagbabawal na values ng domain o values of x allowed input kay cosecant or cotangent. Pag ginawa mo two-sided limit yan, automatic DNE. So, hindi lang 0. Kapag x approaches pi, DNE din 2 pi. Lahat ng bawal sa domain. Bawal na input, no? Ng cosecant or cotangent. Other examples are shown here also. Pagdating kay cotangent, you have the guide like this na pagdating sa right ay always paakyat. Okay? Kapag two-sided, DNE ka agad. Provided na yung nilalapitan na value ng x ay bawal na input ng cotangent. Negative, negative. So, yan. Pagdating naman kay cosecant, kung nalilito ka dahil hindi mo alam yung graph niya, pwede kang kumuha ng, mag-assume ka. Kuha ka ng pinakamalapit kay pi na value. Magpapakita yung mga ay positive. No? Cosecant ng isang pi na nasa left niya na pinakamalapit sa kanya. Papakita niya talaga sa iyo positive na sagot. Ang katumbas nun, we can comprehend now that's positive infinity. Because you are approaching pi from the left. There's no certain value of x onto that. Ang gusto mo lang malaman, dahil nga bawal gamitin, wala ngang value ang cosecant pi kasi this is undefined. Kaya nga left of pi, ganun yan. Positive bibigay niya sa'yo. Right of pi, negative. Bakit negative? You can expect also, gamit ka ng values ng x ng pinakamalapit kay pi from the right. Negative ang bibigay niya sa iyo, class. You can try that out. And others, you have two-sided DNE. Bakit DNE? Kasi walang cosecant 2 pi. And then at the same time, ang left at right ay hindi magkasundo o hindi pareho ang behavior nila. So that's it.